Alright. Hey, here's another 14 minesweeper variants video. Okay. We kind of started working on the 7 plus gallery last episode. I feel like we just gotta keep going. I could also do all the mainline variants, honestly. But I really want to do like larger boards today. Yeah, really do larger boards today. No idea how that's gonna work. So we'll just do the 7 by 7 ones, I guess. Okay. So 1 triplet, 2 product. Okay, this is mine here. One of these are mines. This has to be 1 by 2. There's one mine here. This has to be 1 by 2. This has to be root 2 by root 2. This has to be 1 by root 5. That's fine. Okay, well, we can do a bunch of stuff there, I guess. Yep. Oh, this needs a mine here, sure. Let's see. Unfortunately, triplet kind of works better if you have fewer mines. So like, triplet and product kind of balance. They don't even balance each other out. They work together in pushing that mine polarity even further. Like product also works better if you have fewer mines. So except for ones, one clues in product do require a decent number of mines around them. But all the other clues prefer it if you didn't have that many mines around you. Okay. Do you hear that? I think someone's drilling outside. Hopefully you don't hear that. Okay, so we know either this is a mine or this is a mine. That doesn't really help. I don't see any triplets that could come out of this. Like in the case where this is a mine, you kind of get this because this 2 now must be a root 2 by root 2. I don't really get how that's useful. This could easily be a 1 by 2. You could do something like this, but not that. Actually, yeah, if this was a mine, then this 1 has to be fulfilled like this, because this has to be empty, and that breaks. So this can't be a mine. Sure. Okay, and now these can't both be mines because of triplet, so that's a mine. This is now a root 2 by root 2. Okay. Okay, this 1 and this root 2 clue work together. This is a root 2 by root 2. This means that's a mine. That's... Oh, it's root 2. I read this as a 2 for some reason. I don't know why. Anyway. Yeah, I can probably caught a bunch of these, honestly. Jeez, the drilling is getting a bit annoying. So yeah. Can you caught a bunch of these? Couldn't caught that. Whoa, that was weird. Okay, there you go. This is about as good as it gets. So we know there's exactly 1 mine here. We know there's exactly 1 mine here. We also know there's exactly 1 mine here. Because there's at least 1 at most 1. So, yes. Not very useful, I suppose. Although I guess... By this point, we've already eliminated... hold on. 8 mines remain, huh? And... Okay, so... The idea is I'm fairly certain this is empty and this is empty. The way to think about this is that from these clues, how many empty cells could you potentially have? We know there's one here. We know there's at least one here, but there can also be two empty cells in the case where you get a situation like that. Two empty cells. However, you will note that, for example, in this row, you need some empty cell. And in this area, you also need some empty cell. You can't have all of these being mines, otherwise you break the level disgustingly. So you need some empty cell here, some empty cell here, some empty cell here, and some empty cell here. And that's all 4 empty cells that can exist. Meaning, not only is there exactly one empty here and one empty here, which already confirms this setup, you also need one empty here. The only possible one that can be empty is the middle one, because otherwise you always form a row of 3 somewhere. So this is the one that's empty. These are both mines. All of those are mines. And for this, you have to have an empty here as well as an empty here. The only place that intersects is this one. So this is the one that's empty. These are both mines. There you go. That solves the puzzle. Yeah, very big global argument at the end. Typically that's what happens in triplet, especially when you have a large number of mines towards the end. You're forced to make that kind of deduction. And apparently, according to the game's difficulty setting, all of the combined mine count deductions are all considered a singular rule deduction, which means that not only that, you can also combine them with other rules like I did here. I feel like I combined it with a lot more rules. Like we used 3 different clues here. We used this one, and this one. Actually, no. We kind of used this one, I guess, which is less of a clue than this rule. So sure, I guess. In general, 7x7s will force you to use at most 3 clues at once. In the exclamation mark version, it's at least it's exactly 4, I think. Alright, good stuff. Alright, outside encrypted. Go. We start by coding everything. We know immediately that G is larger than D. G can't be 4, because if it were 4, you'd have disconnected non-mines. Can A be 6? Yeah, actually, quite easily. A can be 6. Either that or F is 6. E can't be 5. Okay, so A and F are 5 and 6. So A is either 5 or 6. I feel like that's interesting in that, well, G is at least 1, but we already knew that. Oh, actually, D is at least 2, isn't it? Because if A was 5, even with mines here, you'd have to have at least 2 mines here. So D is 2, A is 5. G is larger, so G is 3. Alright, that gives us a lot of values. We can immediately do some regular minesweeper with this. 2, 3 means 1 mine here. Oh, that is such a perfect straight line. Okay, either B, C, or E is 4. Those all have very interesting implications, I guess. Not excessively interesting. But also, one of them is 0. Okay. I can see some interesting things, like, if C is 0, that doesn't work out. Because then neither value can be a 4. E and B both can't be 4, so C can't be 0. If C is 4, then neither value is 0, which also breaks, so C is exactly 1. At the same time, B now can't be 4, because that breaks the 1 clue here. So in fact, B is 0, and E is 4. Okay, we can do even more minesweeper related shenanigans here. That one was outside. So you get that. And we can basically solve this as an outside puzzle now. I really want to know if you hear that. You don't? Okay, cool. I was checking the mic there. Apparently you don't hear the drilling that's going on. I don't actually know where the drilling is coming from. I think it's from upstairs. Anyway, It's a bit annoying, but I can deal with it. I don't quite see where to go here. I see that you have to have one mine here, but that doesn't really do anything. If you had a mine here, you'd have to connect to prevent the checkerboard pattern, but that's fine by me. 3 here out of 5, huh? Well, I mean, this is a forbidden pattern. But there are so many ways to not do that. Oh, I see that. Okay, there's a very big potential wall here. This is empty. Yeah, and 6. Okay. Well, you can't have 3 mines here, because that forms the wall. And similarly, you can't have 3 mines here. So this is gonna be 2 mines here, and 2 mines here. In particular, those 2 mines can't be here and here, because otherwise you'd form that same wall. And you can do the same on the diagonally opposite side. Meaning in both cases, you have a mine here and here. We know there's 1 mine here, so this is empty. Now this 6 zone is actually complete. And to fulfill the checkerboard pattern, this is the mine and this is empty. Okay. 2 mines remain. Oh, well there's 1 here, and there's 1 here. So everything else is empty. And that should be good enough to solve like basically the entire puzzle. Very nice. Look at this huge mine structure. It's always very satisfying to see. Alright, moving on. Dual modulo. Okay. Well, this 0 is either 0 or it's 3. If it were 3, how could it be a 3? Well, you can't have 3 mines come together like this, so the 2 extremities must be mines. This mine has to extend out this way. So this is the only way 3 can be fulfilled like this, which means that in both cases this is empty. Now this 0 can't be a 6, because in the case where it was a 3, you'd have this setup. This is a 5. Well, not a 5, this is a 3, meaning this is empty. So in both cases, the outsides are always empty. Cool. You can also kind of use modular arithmetic here. Because they are the same value, the difference in regions must be 0 mod 3. 0 congruent mod 3. Yeah, you know what I mean. Anyway, so this area is 0 mod 3. It's either 0 mines or it's 3 mines. But 3 mines doesn't work because it breaks dual. So that happens. Okay, this one is just a 1, meaning this can't be a mine, otherwise it extends, which breaks the 1. And now these zeros are confirmed to be just be zeros. Now the 1 and the 2 differ by 1 mod 3, so that's a mine. And this 0 is now a 3. These also differ by 1, so that's a mine and that's empty. So one of these are mines, I guess. This 1 is not a 7, it's a 4. But I don't actually see how you could do anything with that. I think either way, these are both empty. The idea is that if this is a mine, it extends, making this empty. If this is a mine, this dual is complete, making this empty. So these are both empty. Ooh, 0. This is not a 6. I think 6 is not possible in dual. There's another 3. With 1 mine here. Then this now can't be a mine because it has to extend. Hold on, let me prove that 6 is not possible first. I just don't think there's a way to make 6 possible. Like, if you start with a mine here, without loss of generality, you can prove that it will either extend this way or this way. Otherwise, they're both empty. I think both empty is horrible, because then all of these are mines, which definitely breaks. So it either extends this way or this way. Without loss of generality, you can assume either one. And yeah, that really does break. So 6 is not possible. I mean, the other way to have this work is if this were empty. But without loss of generality, you can prove that that holds true for every corner, which means all of these are empty, which breaks the 6 even more. So yeah, fairly certain 6 isn't a valid clue in dual. Anyway, with this 3, we know that there are 2 mines forming this dual. There can't be a mine here, which must extend. This is empty. This 1 now must have its mine here, because otherwise it's isolated. This 0 is also a 3. Although there are multiple ways to go about this now. You could have a mine in here that grows outwards. You could have a mine here that also grows outwards, causing that to be a mine here. Maybe that breaks the 4 a bit. Not really. Actually, this 3 is done. Oh, okay. There you go. Keep missing things. Okay. Now things are a bit interesting here because one of these are mines. And in fact, if this is a mine that breaks, because there are 2 mines here which cannot be filled up here. So this is the one that's the mine, this isn't. This must have its mine here or here, or its pair, so that's always empty. 2, I think 2 is just a 2 because it can't be a 5. If we were a 5, you get this. So it's just a 2. So that solves itself, that solves itself. This could be a 4 or a 1, I think. This has to grow out, so it's a 4. This is a 3. This is a 2. Okay, that solves a bunch of stuff. That's it. Cool. 2, 4, 6, 8, 10, 12, 14. Yeah, 7 groups of 2 as per usual. Nice. I think modular math is very cool. Oh, sneak area. Oh, area. Area is cool. Get some really funny stuff like that. Yeah, a 20. Okay, well this 20 must have something here that goes outwards. This 20 must have something here that goes outwards. Although not technically true because you could have this be empty and this be a mine. Yeah. Okay. I mean the idea is just that because your snake is one singular area and is the only area on the board, every clue that isn't a 0 must then just be a 20, because it must be touching the snake. So in essence, this combo basically tells you this mine touches a snake, this mine doesn't, this mine touches a snake, this mine doesn't. Okay, well we know there's something here that causes your dead end. Something here is also your dead end. So you can't have any more dead ends, being these are both empty. That's a mine, which isn't a dead end. Okay, so now this has to have its mine here, which must grow. No dead ends. Oh, alright, this is great. This thing has to go this way, because no dead end. Has to at least touch here. And there are 3 mines remaining, so you can't go all the way in here. In fact, you can't go here either. Well, you can actually. Oh, but you can't go here. Okay, that gives me stuff. There you go. Yeah. This snake area is such an interesting combo. It also makes area playable, finally. There are some really complicated setups though in snake area. So it's not that easy to spot sometimes, but this one was a particularly easy puzzle. Alright, balance, liar. Okay, well there's 3 mines per row and column now. 2-5 is definitely containing a liar somewhere, because they have to differ by 3, but there's nowhere to put 3 mines outside. So nothing else in the column is a liar? This 3 is complete then. Oh, actually by column E, these are all mines, just by the balance rule. And now 3-4 must have a liar in it somewhere. Oh, really? Oh yeah, no, you could have all 3 of these be mines, yeah, okay. My bad. Yeah, I was thinking there's no way this 4 can have more mines than 3 outside, but that's clearly wrong. Okay. This 2 can be telling the truth, even with balance. This 5 can't be telling the truth though, because if it was, then column F experiences an issue. So 5 is the one that's lying. There's 2 here, there has to be a mine there as well. That's actually true regardless of whichever is lying. These can't both be mines, so this is a mine, which completes column D. This 5 is lying. So this 3 is telling the truth, that's a mine. There's 5 standard truth, these are both mines. This column is done. 3 means that there's 2 mines here. 4 means that there's at most 1 mine here, which there must be, because column B already sees 2 mines in those cells, so this 4 is lying. And actually this 4 standard truth means that, which completes the column. Alright, liar here, liar here. Keep getting notifications. Okay. Row 3 is done. Okay, liar, liar. Cool. 1 lie means that's a mine. That completes the 2, which is lying. Column G is done. Row 4 is done. Column F is not done. But row 6 is done. Row 7 is also done. 6, 7. Sorry, this is horrible. Anyway, there you go. Solved. The final steps are like basically trivial. I kind of wonder what else I can do besides just playing this game on this channel. Sorry, I was doom scrolling. Alright, quadrant deviation. Okay, quadrant deviation don't seem too bad. Quadrant deviation do have some peculiarities though. Like you can't use typical quad arguments anymore. Like a 2 in the middle of the board is fine now. You can always, in fact, a 1 works. You can put a mine in the middle, and literally anything around it can be mine, and it doesn't matter. So now 2s are useless, unfortunately. Okay, 3 and 4. But as long as I can find some line that works. Things still work out. Some line of arguments that works, I mean. I don't know. For all I care, these 3 could all be empty. Mine's here, here, and here, here. This works. If this is empty though, I feel like interesting things happen. Yeah, if this is empty, then these have to all be empty because you have to have at least 1 here and 1 here. You get mines here and here, and that breaks the 3. So this can't be empty, this actually has to be a mine. Not super useful, I guess. I don't really see any lines I can proceed with. I do know that these can both be empty by that previous deduction. Because both of these will be mine. So there is something here, which means that everything else is empty. So this 2 was useful after all. Okay. Well now this 2 has a mine here, so this 4 is done. There's 1 mine here, so the 2 and the 3 now clash. You got this as your typical 1-2 pattern. What? I mean, there's 2 mines here, yeah. Oh, there's 2 mines in here. This has 2 mines in it. So this 4 means there's a mine there. Don't quite see how that's useful. I guess it might work with a 3. Yeah, actually, you can't have mines here and here because that literally breaks the 3. So for this 2, you have to have this be a mine. There's one mine here. So for this 3, this rectangle has one mine remaining, which must be in the middle. Because if it were here, for example, then you have one quad that's empty. So these are both. So these are all empty. 2, 3 differ by 1, so that's the mine that it differs by. That solves a bunch of stuff. A bunch of trivial stuff, I might add. This 3 is done. This 4 is done. This 4 is done. This 3 is done. This 4 is not done, but this 3 is. That completes this 4. This 2 is done. That completes that 2. And these are both mines. Doing a lot more coding today. I'm a bit tired. I kind of just woke up. I don't know if you can tell. My voice typically gets a lot lower when I wake up. Alright, so let's keep going. Ooh, product. We've come full circle. Okay, 2-5. I'm fairly certain these can't be mines, because if they're mines, they get immediately isolated like that. 2 root 5 is super far away. 2 root 5 is like root 20, which is a 4 and a 2 away. So these can't be mines. I'm even fairly certain this can't be a mine by the same principle. So now this is 2 root 5. It sees a 2 and it sees a root 5. This can't be a mine. This sees a root 5, but yeah, you can always escape like this, so anything around it can still be mine. This can't be a mine though, if I connect it. Actually, the root 5 is really cool in that you can't have anything that's root 2 away. You also can't have anything that's 2 away, so that gives you this very nice aura around the grid already. Okay, 2 root 2 solves itself even more, and at this point, almost so that we can chord something. I guess not. This 4 could be a 2x2. It could also be root 2 by 2 root 2. Which I feel like it might not be. Actually, I'm wondering how mines from here can cross over. Like, one way I'm seeing it is like this. It's also possible to do it like that. Is there any way to completely block them out? Like, if this is empty, you have to bridge like this, which is definitely broken for this root 5. So this is always a mine. Then you can either bridge this way or this way. Root 2 seeing a root 2 and a 2 is fine. But, I guess it can't go this way. Although I can definitely do some weird stuff like this, I guess. Yeah, that's perfectly fine. If this 4 was a root 2 by 2 root 2, you can remove all of these being mines, yeah, and that actually does, I think, break a bunch of stuff. In particular, I think it brings this to root 2 right, like, immediately. So this 4 is 2 by 2. Okay. Can I chord anything? No, still no. Okay. What if there's some number of mines here which have to escape this way? So that's already forced. There are also some number of mines from here that have to escape this way. Can this be this? No, because that's empty, which creates the wall. What? Oh, because it can be. Wait, what? Oh, this is a root 2. I read this as a 2 again. I think I did it like just now. Horrible stuff. Okay. So like, if this is a mine, it's gonna have to go up this way, making this empty, meaning it has to go up this way. I mean, otherwise it needs a root 2, so there's always a mine, I guess. Yeah. If this is the mine, it has to go out this way, which you have to break, so that's empty. Now I'm stuck. Is this done? Yes, kind of. If this is a mine, it kind of has to grow out this way. Well, we could also do this. This needs to see something two away. So either sees a mine here or a mine here. I mean, this is always possible. Surprisingly difficult. I guess if this is a mine, then that breaks. Yeah, because the disconnection. So this can't be a mine. This can't be empty as well, so that's a mine. I mean, this is a two. This is a root 2 by root 2. What? Oh, some empty cell. Okay, I see, I see. There are 10 mines remaining. We have to use mine count this time. So there's at most one mine here and at most one mine here. That literally means every other cell has to be a mine. So mine, 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 mine. Okay, and that solves this route too, I think. This is to escape. There you go. Cool. Again, not a very good solve, but I'll take it at this point. I'll take it. Alright, let's keep going. Triplet. Again, encrypted this time. Okay, well, by typical encrypted, I can do that. That's a lot of that letter. A lot of letter D. B could be a 3, I guess. If D were 2 and E was 1. I see that B is the sum of E and D. So in fact, B can't be 0, because then E and D are both 0. In addition, actually, I think neither E or D can be 0. Because if they were 0, for example, if D was 0, then whatever E is, B would be the same. Which is impossible. So in fact, neither of these can be 0. So that gives you E equals 1, D equals 2, B equals 3. Wow, look at that. Okay, A is 4 or 5. A can't be 5 because you'd have a triplet. So A is 4. That's a mine therefore, which solves a bunch of other stuff. Okay, 2 is done. One of these are mines. 4 means that's a mine, so that's empty. That's a mine. 3 and 2 must be done like that. 4 is done. That's empty. That's a mine, that's empty. That's a mine. Oh, did I not see? Ah, the 4's already. Alright. Typical, typical mistake. Should have caught it. Yeah, I should have caught it like that. So C is 5, huh? Okay. 4 is done. That's empty. That's a mine. That's empty. 4 with 2 mines remaining. All 2 mines that exist, so that's empty. That solves it. Okay, cool. It is possible for 6 to exist in triplet. It's rare, but it's possible. Alright. Outside modulo. Okay, this can't be a 3. Because if it was a 3, isolates itself. So these are all empty. 2 is done, 1 is done, so this is a 3, meaning that's empty. Forbidden pattern means this is not a mine, that's a mine. This is a 3, so there's 1 mine here. Forbidden pattern means this one's the mine. 1 and 0 differ by 2. So whatever's here, this must have a 2 mod 3 mines differing from it. This could be a 2 and then it could be 1 mine here. That's entirely possible. This one is a 4, so this can't be empty, otherwise you have a mine there. 1 mine here means that 0 is a 3. You could have a second mine here, this being empty. No. Actually, I think this one is a 1, it fails, because it's 0, that can't be a 3. I know there's 1 mine here, but there's not enough space to put 3. So this 1 is actually a 4. Yeah, and the 0 already sees 3 mines, so that's empty. Forbidden pattern, so that's empty, that's a mine. This 1 is a 4, so this can't be empty now, otherwise forbidden pattern. There's 1 mine here, this 1 is also a 4. So this can't be empty because forbidden pattern. Okay. In fact, I know there's one mine here exactly. Not quite sure how that's useful. I guess this has to grow outwards to not be disconnected. 2 ODCs, 2 mine, it can't be any higher than a 2, so that's empty. 1 sees 1 mine here, it can't be a 4. So these are both empty, that's a mine. Forbidden pattern, mine. Okay, I really like this pattern of like, yeah, there's a forbidden pattern there, therefore that's a mine. Wow, that's really clean. Okay, so this is either a 5 or a 2. I think both are possible right now. This is definitely a 4 because it can't be a 7. So if this is a 5, this 4 is complete. Ah, okay. If this was a 2, this 1 must be completed like so, and that actually breaks because you isolate non-mines. So this 2 is a 5. That completes the 1. This 1 is complete. This 0 can be done. This 0 can also be done. 0 is done. 1 means someone in there. Therefore that's empty. 2 mines remain, which are these 2. Oh, I didn't know Modular had that pattern like that. I think Outside actually has that pattern a lot, where there is exactly one space you can't put an empty cell in, otherwise it becomes a forbidden pattern, and then you get this like long chain. Yeah. Okay. Let's do another. Dual area. Ooh, fun fact about dual area. Logically, every area is an even number. That's all I can say. Okay, cool stuff happens here. For example, one of these are mines, which form your area. You'll have to grow out this way, but that will incidentally complete this too. So this is empty. You get a very similar idea here where this will go out here or here, which completes this too. So these are both empty as well. 4. 4 must see 2 distinct areas. Although there are a few ways to do it. I see that this happens in both cases, right? Although, like, in the other case, there's a bit of weird geometry to it. If you had the 2 areas be here and here, this one becomes isolated. So your areas must include this as one of the areas. And is it the same in the other side, where this is a mine, this is mine, this is empty? Maybe not. This 4 could potentially have a mine here and here if this one grew out this way. And that's completely fine to me, I think. So I think there's no actual geometry here. I was gonna say that this has to be a mine, but it doesn't. Well, interestingly, I think this has to be empty all the time. Because in the green case, this 4's other mine is either here or here. If here, it goes upwards. If this, then wherever it grows, this has to be empty. In fact, it has to go this way, by the way. So, like... yeah, this is always empty. Sweet. Okay. Now, I'm fairly certain that this 4 is either... this 4 has to have a mine that touches this 2, I think. Because if this was a mine, it has to touch the 2. But if not, you have to have mines here and here, which must grow out this way and this way, which also touches the 2. So the 2 is being touched by a mine from this 4. Meaning this is empty, I think. Yeah, that works. 2. If this is a mine, this is empty. If this is a mine, wherever it grows, it makes this empty, so that's also empty. And whichever mine comes from this 2 also touches this 2 somewhere, so this is empty. Oh my goodness, the pattern keeps growing. Empty because dual rule. That's a mine. 4 means that's a mine, that's empty. That's a mine, that means that's empty. Okay, we're getting somewhere. This now can't be a mine because it has to go up and bricks. That's a mine which must grow. This is a mine which is empty. This is a mine that must grow. This is a mine which grows. This is empty. This is a mine which grows, and that solves the puzzle. Ooh, very satisfying. This is actually a really good puzzle, despite being machine generated. Procedurally generated, I guess is the right word for it. I really like the puzzles that show you a certain technique and then proceeds to get you to use that technique over and over. It's very satisfying because you feel like you're legitimately learning and applying that technique. So yeah, that's really cool, I guess. Okay, I think it's good to stop here, honestly. We could try one more. Just one more. Snake Liar. Okay, well neither of these can be mines. This can't be a mine either. Otherwise, in all cases, it has to grow outwards, causing this 0 to be a 2. One of these are liars, obviously. They can't both coexist and be equal, and be telling the truth. However, I do realize that you either have mines here and here, or if this is empty, this is also a mine. That's always a mine. If this is a mine... Actually, if this is a mine, then both of these are liars, which breaks. So this can't be a mine. Truth-telling, liar. Truth-telling. 3 is done. This has to grow outwards. This can't be a dead end. Because we are both dead ends would now be in equal parity, which doesn't work. So this has to grow, meaning this 4 is lying. This could actually be a mine. No, it's a 5. This 4 is done. You get that. This 3, well, kind of its dead end be here, because you get this really short snake. So this has to grow out this way somehow. This 6 is a 6, I guess. It is a 6, yeah. It's telling the truth. Oh, we know this is a liar. That's a liar. Okay, so that's a mine. That's a mine. This has to go outwards. This 4 is a 3 or a 5. It can actually be a 3, I think, because you could have a dead end be here. Although I'm not sure if we have enough cells for it. Like, if these are both empty, we only have 6 cells remaining, 6 mines remaining. So the shortest path that exists is in fact the only path you can take, which breaks this 6. So I feel like this 4 can't be a 3, it has to be a 5. Okay, this must now go outwards. This now can't be a dead end. And that's actually true because the parity is the same, so yeah. This is the mine. That's empty. This 1 is lying. Also, because there's only 2 mines remaining, you can really only go up to here. Everything else is dead end. Liar, liar. This is empty. This goes outwards. This one already is a 2, so that's empty. Ooh, snake puzzles. Fun as usual. Okay, I kind of speed solved that, but you know, that's typically the only way you can actually get real progress in this game. So I'm going to quickly log this into my tracker. I have a not so functioning tracker. That's okay. Not so functioning is better than non-existent. Let's go look at this. Okay. The next one I'm expecting to be balance and cross. We haven't seen a cross puzzle today, have we? We haven't. Wow. Yeah, we went... we started from like here, I think. Triplet product. And we went down this diagonal, we went here. So I'm expecting the next one to be here. Balance cross. Really surprised we haven't seen a cross this episode at all. But okay. I guess that'll be it. I'll see you guys when I next do this. Bye bye.